Right, in terms of transformations, the first thing we're going to look at is translations. Now, as I may have mentioned in class, translations are addition functions or addition operations. And it looks like this. We've got this x dashed and this y dashed. That tells us the new value of x and the new value of y. That's what it's saying there. So what we did, we set that up in the matrix. So we've got the new value of x, the new value of y, in a 2 by 1, and that equals x plus a and b, where a affects the x values and y affects the y values, and it's always a plus. So we rewrite this, so we can take our top line and write that as x dashed equals x plus a, and then from there we work out that x equals x dashed minus a. Same with y. Y dashed is the bottom line, so y dashed equals y plus b, which implies that y equals y dashed minus b. So basically what we're looking at is we're taking a value of x or y, we're performing an operation to it, and then we end up with a new value of x or y. That's what the x dash there represents. And then what we want to do, we want to write that again in terms of x. That's why we've got x and y here rather than the x dashed. So let's have a look. Sometimes you'll be asked to change a point, which is what we've got here. Other times an equation. So if you're asked to do it to do a point, what you do is you take your set of coordinates and you write that in a 2 by 1 matrix with your x coordinate on top and your y coordinate on the bottom. So over here we write 2 and 2 plus 3 and negative 1. So that's what's going on here. We've got our 3 and negative 1. So from there, 2 plus 3 makes 5. 2 plus negative 1 will give us 1. So this point has now become 5 and 1. Okay, when we've got an equation, and I guess that if we have a look at it, what this actually means, this kind of matrix, what's it going to do to the x value? It's going to move it by 3 to the right. And what's it going to do to the y value? It's going to move it down by 1. So 2 moved, so we've got a point 2, 2, moved 3 places to the right, we end up with 5. 2 moved down by 1, we end up with 1. Now, it's not like with an equation where the sign for x is the opposite. So if x is minus, so normally if we've got say x squared, which then maps to x minus 2 squared, we know this moves across to the right too. With this, a little bit different. It's whatever the value is. So if it's a plus, well then it moves. If it's a plus, well then it moves in a positive direction. Okay, so a little bit different when we have an equation. So over here we've got y equals 3 plus x plus 3, and that is being translated by this matrix here, 2 and 1. Oh, sorry, negative 2 and 1. So what we do, we set this up like this. So we say x dashed y dashed equals x y plus negative 2 and 1. And from there, x dashed equals x minus 2 and y dashed equals y plus 1. So now the next thing, we say that x equals x dashed plus 2 and y equals y dashed minus 1. Now we swap over our values. So whatever we had for y, that now becomes this value here. Whatever we had for x becomes this here. And we just substitute and add or subtract. So instead of y, we're going to write down y dashed minus 1 equals, and instead of x, we're going to write x dashed plus 2, and then we still got our plus 3, so we're going to put a plus 3. So then this becomes y dashed equals x, 2 and 3 makes 5, plus 1 will make 6. So we've got x dashed plus 6, and then we just rewrite that as y equals x plus 6. So that's how the equation gets mapped. Depending on what kind of equation, if it's a squared, well then if it was y equals x squared, well then you replace that in the proper equations. But you just follow this process for whatever the equation may be.